Let us now do a few problems. A 2-pole 50 Hz induction motor supplies 15 kilowatts to a load at a speed of 2950 rpm. The first question is find motor slip. B is what is induced torque under these conditions. Next question is what will be the operating speed if torque is doubled. And finally, how much power will be supplied when the torque is doubled. So before you see the solution, you can try this for yourself first. First we will write down what is all the information that is given. First we have the number of poles, it is given as 2. The frequency is given as 50 Hz and the power output power is given as 15 kilowatts. And finally the speed, motor speed is given as 2950 rpm. Okay. Now the very first question is you have to find out the motor slip. What is the expression for slip? This is the synchronous speed minus the actual speed as a fraction of the synchronous speed. Okay. So we know ns, the synchronous speed, is equal to 120 f by p. We know all of the values. 120 into 50 by 2 is going to give you 3000 rpm. Okay. So the slip you are going to get 3000 minus 2950 by 3000. So this, if you calculate, you are going to get 0.0166. Okay. Next, this is the slip. What is the next question? What is the induced torque under these conditions? Now we have the output power here, and from here how do you find the induced torque? Since there is no information, no other information that is given, we will assume that there are no rotational losses, so that the induced torque is same as the output torque. So you can write assuming rotational losses to be negligible, we are going to get the T induced torque is equal to the T output torque, and from T output torque you can find out, because the output power is given, divided by the actual speed omega. Okay. So output torque is given as 15 kilowatt, so 15 into 10 cube divided by, we know the speed in rpm, so we need to find in radian per second. So what is the conversion formula? 2 pi n by 60. So n is given as 2950 divided by 60. This, if you calculate, you are going to get 48.6 Newton meter. This is the induced torque. What is the next question? You have to find out operating speed if torque is doubled. Okay. So how to solve this? We know that the normal operation is usually in the linear region. Okay. Linear means the torque will be proportional to the slip, right? As torque increases, the slip will also increase. This is the torque speed characteristics. This is torque and speed is increasing in this direction, but slip is increasing in this direction. So as torque is increasing, slip is also increasing linearly. Okay. So you have to write torque is proportional to slip. This means that if T is doubled, then slip S is also doubled. Therefore, what will be the slip? 2 times 0.0166. Thus, you are going to get 0.033. From here, you can find out the speed. What will be the speed? 1 minus S times synchronous speed. Okay. So 1 minus 0.033 into 3000. This, if you calculate, you are going to get 2901 rpm. Next, what about the last question? We have how much power will be supplied when the torque is doubled. Okay. So how to find out the power from the torque? We know power is equal to the torque into the speed in radian per second. So now we know the torque, it is doubled, that means 48.6 into 2 into what about the speed? 2 pi n by 60. 2 pi n we got as 2901 divided by 60. This, if you calculate, you are going to get 29.5 0.52 kilowatt. The next question we have, the figure shows per phase equivalent circuit of a 2-pole 3-phase induction motor operating at 50 Hz. The air gap voltage Vg across the magnetizing inductance is 210 volt RMS and the slip S is 0.05. The torque in Newton meter produced by the motor is. So first we will write down whatever information is given apart from the parameters in this diagram. Okay. So what do we have here? The number of poles is given as 2. The frequency is given as 50 Hz and the voltage Vg, this is given as 210 volt. Okay. And slip is given as 0.05. Now we need to find out the torque. Now here you can either use the final expression in terms of the voltage and these parameters, or you can simply write the air gap power divided by the synchronous speed. Okay, if you remember the formula, well and good, otherwise you can start from the very basic. Torque is equal to power divided by the speed. So the air gap power is nothing but 3 times I2 dash whole square into R2 dash by S, that is the power dissipated in this resistor, divided by omega S is the synchronous speed in radian per second. Okay. So now we can find out each of the parameters. What is I2 dash? This will be the current I2 dash. Now Vg is known, Vg is given as 210 volt and the impedance is given. We can easily find out I2 dash. So you can write I2 dash is equal to 210 divided by 0.05 divided by S plus J 0.22. Now the slip is already given 0.05. So since we need only the magnitude, we can find out magnitude I2 dash. You're going to get 205.27 amperes. Next R2 dash, we anyways know it is 0.05 and S is given as 0.05. We have to find out omega S. So what will be omega S? This is equal to 2 pi by 60 into 120 F by P. We know frequency, it is given as 50 Hz, P is given as 2. So if you calculate this, you are going to get 314.15 radian per second. Okay. So these two values if you substitute here, then you are going to get the torque value. 3 into 205.27 whole square into 0.05, R2 dash value is given as 0.05, S is also given as 0.05 divided by 314.15. Okay. So you are going to get 402.37 Newton meter. One last question here. A 3-phase 50 Hz 6-pole induction motor has a rotor resistance of 0.1 and reactance of 0.92 ohms. Neglect voltage drop in stator and assume that the rotor resistance is constant. Given that the full load slip is 3%, the ratio of maximum torque to full load torque is. Okay. So once again you will first write down whatever information is given. The frequency is given as 50 Hz. The number of poles is given as 6. Now R2 is given as 0.1 and finally X2 is given as 0.92. We have the full load slip as 0.03. Okay. What else is given? The voltage drop across the stator is neglected. Okay. So that means whatever approximation we have discussed, it is valid to take that approximation. Now what is it that we require? We require the ratio of maximum torque to full load torque. Okay. So we have already discussed the value of torque as a ratio of T max. What was it? 2 by Sm by S plus S by Sm. Okay. Now what do we want? We want the inverse of it. That means T max is in the numerator. Also, this is the full load torque that we want. It is simply any other slip. Okay. Here the full load slip is given as 3%. So T here is the full load torque and S here is 0.03. As simple as that. So T max by Tf is going to be Sm by Sf plus Sf by Sm divided by 2. So we have the value of SF here. The full load torque is given as 0.03. What we have to find out? SM, the slip at which maximum torque occurs. So we know this anyways. It's a very simple condition. S max is equal to R2 by X2, the rotor resistance by the rotor reactance. So R2 is given as 0.1 and X2 is given as 0.92. So this you are going to get 0.108. Therefore, T max by Tm, you are going to get 0.108 divided by 0.03 plus 0.03 divided by 0.108 divided by 2. This you are going to get 1.9